Ladies and gentlemen, welcome after the break, and we are back to our presentations during the BEECOME Congress. Anna Gajda, my colleague here, is going to speak in a moment, so I'm left alone for a moment. But before we move on, let me introduce the profile of Anna Gajda, besides that being the moderator of this meeting, and she also contributed to organizing this wonderful event that we are taking part in. She is also going to speak. So, a veterinary doctor, Anna Gajda, head of the Pathology and Diagnostics of the veterinary department at the Warsaw Agricultural University. She is a researcher and beekeeper. She's been working with bees for 13 years and also lectures on bee diseases in Polish and in English, and she is focused on bee viruses and nosema, but also is interested in other diseases of bees, researches as well into colonies, dead colonies or decaying colonies. She's a member of International Colonies Association that focuses on losses in bee colonies, and she shares her knowledge in training and conferences. She's also an author. She writes for various magazines, a co-author of the Atlas of Bee Diseases and 13 papers for a calendar for 2021, for beekeepers calendar for 2021. Professor, the floor is yours. Thank you very, very much for this wonderful introduction. I'm going to talk today about what we've heard a little about before, and I'm going to talk about climate change and the impact on the diseases of bees. Now, we know very, very well that the climate is changing. This is beyond question. And what are the consequences of for bees? Now, in the temperate climate, where we don't have when we don't have maggots during winter time because of the temperature, we have problems. Obviously, the brood is also gone, and because of the varrosis, we can see the photos that we are showing are samples taken from samples that I get from beekeepers infected with infected colonies, and the most dangerous of the viri is the DWV, deformed wings virus. The beekeepers know it very well because the deformed wings are highly visible, as we can see. The varroa destructor. This photo was taken very quickly, and I didn't take long to find these particular specimens. So we can see that the mites are really walking on those bees and those poor bees with deformed wings, and we can see that this colony is not going to survive. And we also have the ABPV infection, and it's been calculated if we have 6,500 mites in the colony, so to speak, and plus the ABPV virus, and there is a good chance that it will have that this virus will be, because it's quite popular. We know that this colony is not going to survive the winter. For the DWV, there's even less mites that are condemned that family. It's only 4,000 in a colony, and the family is gone. Now, I'd like to also mention something that we've heard before, that because that we have the heat waves or extreme heat and the shifting of seasons that restricts the number of forages and the shifting of the blossoming season. So, for example, everything is blossoming or nothing is blossoming at any given time. But plus, you have the wrong kinds of weather. For example, a drought. With a smaller number of flowers, there will be more insects. And I'm not only talking about the honeybees, but all the pollinators. They all are in constant touch and they will share pathogens. And this pathogen transmission on forages is very frequent. And let me give you a visualization. As you can see, a bee with viri, with mites, that flies to a flower, and she will drop some of them on the flower. Nosema, varroa, they will all be there on the flower, and it's been tested that the varroa destructor can wait for up to 3 days for another bee, and there comes this poor bee, that is healthy, picks up the varroa, the viri, nosemosa perhaps, and it brings it back to the hive, and the pathogens are passed on. They multiply and then they passed on to the colony, and the colony is going to be sick, and the foragers will fly out and leave even more of those pathogens on the flowers, on the forages. And this is like a vicious circle. Apart from these viri, the varroa, we have a good chance of having the Tropilelaps, which is something that lives off the brood. They are a little bit too thick to go between the plates of the armor of the bee, but on the brood they feed, because obviously the skins are soft. And Tropilelaps can come to Europe because it is thriving in Asia, where the brood is a non-stop, has a non-stop season. But in Poland, we can have it up to December, and in 10 years' time, maybe earlier, even if we don't isolate the mother, the queen, this brood will continue all year round, and Tropilelaps will be able to survive the winter, because right now it cannot do this, even if those brood breaks are short, because Tropilelaps cannot survive for too long on grown-up mature bees, because they cannot feed off them effectively. So you can see this mite on the right-hand side. This is obviously a huge enlargement, but it's not so easy to diagnose. This is a Tropilelaps. Obviously, our inspections are very quick. They can walk on bees, can be also in broods. They can be oval, they're brown, and when we see those small brown insects walking on the brood, we think it is varroa, and we don't think. I'd like to encourage you to start thinking about it, because Tropilelaps can sooner or later crop up. You have the various phases, development phases, and you can see clearly how they're built. They're a little chubby, and that's why they cannot feed on the grown-up bees, which is a saving factor right now. This is brood out of its cells, stricken by Tropilelaps, a number of varieties. All of them are dangerous to almost all of them are dangerous to the honeybee, and the symptoms are very similar to varrosis, and that's why we have a problem with diagnosing early on that this passenger parasite is is entering Europe, and you can see bees, as you can see here, bees with deformed wings, and also in various other stages you can see those wings deformed, and that's why I'd like to sensitize you to look closer at those parasites, even though we know that we need to control Varroa destructor infections, and once we notice it, let's have a closer look to see if this may not be a Tropilelaps. And let me move on to the reduction of the quantity of forages and the shifting of the blossoming seasons. So again, you have the pathogen sharing, which will increase in frequency. Transmission of the pathogens will be easier, and nosemosis is coming in, both A and C varieties, because they can wait for quite a long time on those for those unlucky bees that will try and get into to the nectar, and both in the pollen and the nectar. Nosemosis nosema can be there, and these bees will bring it to the hive, and because when there are no flowers, no forages, maybe there is roaming behavior. Bees tend to look for something easy, and obviously bees wander with strong nosemosis. They are hungry, they find it more difficult to find the right hive. They get to a wrong one, and you know what happens. If they want to be admitted into their hive, they have to offer something, and normally this is a drop of nectar, and God forbid there are quite a lot of nosema spores. Another colony contracts the nosema, especially nosema C. This one is nosema apis, which causes the A-type nosemosis, where beekeepers world over know it very well, because it's easy to detect, to diagnose, because it has these characteristic symptoms with those poor crawling bees with long abdomens. You can see one of these looks almost like a queen mother with his abdomen. Also there are stains, and those crawling bees, instead of flying, they are too heavy because their feeding tracts are full of things that they cannot digest. They are also hungry, and they are not able to fly, and also diarrhea on the combs, on the walls. And you can see that this diarrhea is a source of spores, of huge quantities of these, and these combs we withdraw. We don't do any recycling, because that is going to be dangerous.
But we also have nosemosis C, which is very widespread in most of Europe, which to that extent, in fact, that it is eliminating Nosemosa apis. Wherever it's warmer, Nosema serene feels better. In cooler countries, Nosema apis prefers to develop. But it is said that Nosemosis C expansion is very, very quick, and it is slowly replacing Nosema apis from apiaries worldwide. And here, unfortunately, there's no symptoms. It is called a dry nosemosis. As I said, it prefers warmer regions, so it will be present in Poland as well. Prefers warmer climate. And in warmer countries, this is a big threat. Spain had a huge problem with nosemosis C, losing a lot of colonies because of this disease. In order to make things worse, unfortunately, my presentations are always about terrible things. because we have less forage, less availability of forage because of climate changes, we see that American foulbrood is doing very well. Because this is a bacteria that in bad conditions changes into a spore. And the spores are very, very resistant to environmental conditions, and it is extremely difficult to get rid of them. So as soon as we have the bacteria and its spores in a colony, these spores are everywhere, on the bees, on the brood, on the combs, and the bees spread it everywhere. So once we have a strong, healthy colony, and they decide to rob a weaker colony, weaker because of the American foulbrood, we know that the strongest colony will be the first one in our apiary to catch American foulbrood, if there's any in the area. The wandering bee mechanism is something obvious for you. The situation is very similar to nosemosis, namely sick bees wander to colonies that are not theirs, unfortunately bringing the American foulbrood and its spores in their nectar. Because the bees are hungry, because of the hunger, a lot of bad things are happening, unfortunately. And we can see such a view. This is very classic. Here we can see something is wrong with some of the cells. We can see that they look moist, greenish. Something is wrong, and this is indicated by red arrows. Green arrows point to cells that look okay. Still, in these cells that look good, we have been finding dead larvae infested by American foulbrood. So American foulbrood does not have to manifest classically. It may manifest without any obvious symptoms. Here you can see some more examples. Obviously, American foulbrood is usually the disease of summer. Majority of beekeepers know that the classical American foulbrood, the dominating one, has a symptom of the remnants of a larva that looks like this. When we stick a match in, we can see something gluey. We cannot even identify a larvae. Going back to brood that I started with, we know that we have brood, we have warm temperatures in winter, and then the queens lay eggs. And once we have brood, even if spores of American foulbrood are not very numerous, then the brood will catch it. And we may see a situation. This is a photo of American foulbrood in January. Yes, we have been diagnosing AFB also in winter, and of course we have to report it. Obviously, we are not doing anything because we do not want to harm the colony. So we can start eradicating American foulbrood when weather permits. But these situations do happen. I hope that on this photo you can see the black content of the cells, where you can see these black crusts at the bottom. These are dead larvae that have been killed by the bacteria. We can see certain caps that look wet, they look bad. That's January brood and January American foulbrood. We can also expect chronic bee paralysis virus more and more frequently, because this is a disease that reacts to adverse environmental conditions. Because, of course, there's a lot of viruses present in the environment, and say if we have endemically the chronic paralysis virus in our region, and nothing is going on because the weather is good, the bees are flying around to forage, and all of a sudden we have extreme conditions, drought or long rain spell, then the bees have to stay in the hive. If there's too many bees sitting in a hive for too long, then definitely they keep walking on each other because there's a lot of them, and they are removing more and more hair on their body. As a result, they get a lot of small injuries, and then the chronic bee paralysis virus is very happy to enter the organism, starts multiplying, and then we see the symptoms just like on this photo. We can see bees that are black, shiny, a bit smaller, that still keep flying, but then they lose the capacity to fly. Here I hope, hang on, I was thinking that you would be able to see the movements of the wings. Here you can see a bee with chronic paralysis. Oh, there you are. Please see what are the movements. If anyone has seen a bee in a hive, you can see that this is not a normal behavior. She's not a black robber yet, because this is the second form, where we have first neurological symptoms, but you can see this bee will not be able to fly, and it's actually spreading, disseminating the virus everywhere around. However, here we should have another video, maybe we'll be able to show it. We have this black robber that cannot fly anymore. There we are. Please see. This bee also shows the classical non-natural movements of the abdomen, of the legs and of the wings. They can't fly anymore. And unfortunately these bees will die. Yet another disease that reacts to the adverse environmental conditions is the Sac Bird disease. It's called Sac Bird because brood looks like a sack with liquid, and they die off. Here we can see that again the virus is present in a bee colony, and if bees can forage, especially the older bees that are the carriers of the vectors of the virus, then nothing happens because they are foragers. They are not in touch with brood much, and this is why they do not provide the virus together with the food. And then, if the weather is bad, we know what the bees are. The bees are very hardworking girls. They do not like not doing anything. So when they have to stay in the beehive, they will try to feed the brood. And here you can see that larvae, 3 of them actually, that dried off in the cells, and they are very characteristic because they turn to like little mini boats with the heads and the edges of the larva lift, and they look like a shell or a boat. It's very easy to remove them from a cell. And now, if weather conditions very suddenly worsen, and for instance in the spring is very cold for a very long time, we may have the Chalkboard disease. Excuse me. The Chalkboard disease is a disease very well known by most beekeepers. This happens when the brood is malnourished and not taken care of. And then you can see the mummies that you can see on this slide. Here you can see, you can collect a whole... I'll have to ask for water. Sorry, you can collect handfuls of them. Definitely talking about diseases is not good for me. Alright, so we have a handful of mummified breed. And another disease that responds to cold weather, where the bees cannot warm up the brood, is European fall brood. European fall brood is called a mild disease because it's not a disease that's as terrible as the American one. Sorry, and they are very characteristic. They have very characteristic symptoms because in the majority of cases you will have the brood uncapped. They will be moving around, they will be showing the back or the head. And it is not white, even and shiny. I guess this is the end of my presentation. This is basically it. Thank you. That was the last slide anyway.
Dziękujemy bardzo za